Good morning. Now today we will start the next unit. Unit 3 we have completed. Now it is our last unit. Unit 4, digital filters, and this is the first class on this unit. The topic for today is IAR filters or frequency selective filters. So let us first of all see what filtering is and what are the various types of filters. Just a theory part. Okay. Now this is just you have to read through. Filtering a signal means it is nothing but changing the characteristics of the signal in the frequency domain. Generally speaking, filtering is a process that transforms or that converts the spectrum of a signal according to certain rule of correspondence. Anytime a processing operation performed on a signal uh, involves modifying, reshaping, or transforming the spectrum of signal in one way or the other, then the processing involved will be referred to as filtering. So, filtering is nothing but changing the characteristics of a signal in the frequency domain. That is, you are just modifying the signal according to your needs, and that modifying it can be either reshaping the signal or just transforming the signal or the spectrum of the signal in one way or the other. So all these processes is altogether called by the name filtering. Now, filtering can be classified on the basis of their operating signals, such as analog or digital. In analog filters, the input, output, and internal signals are in the form of continuous time signals that you know, whereas in digital filters, they are in the form of discrete time signals. Now, this digital IAR filters evolved as a natural extension. That is, it is an extension of analog filters and is designed through the use of analog filter methodology. So this IR filter is a one type of digital filter and it is an extension of analog filter. That is, it is made from the modified versions of analog filters. Now filters can be classified in various ways according to the task for which they are designed. Here we give special focus to frequency selective filters. So before going into details, we must know what is frequency selection. Frequency selection means if the input signal contains contributions in some frequency intervals and we want to modify them, it can be either attenuating or suppressing. For example, the components of pertaining to a certain frequency band and preserving or enhancing those pertaining to another frequency band, etc. So that is, in other words, this type of filtering. This is the definition that you have to study. That is, it means, or frequency selection means, it is a type of filtering which is used to select one or more desirable bands of frequency components and simultaneously reject one or more undesired bands. So this is the definition of frequency selection. What is meant by frequency selection? That is, you are selecting the desired frequency bands, whereas at the same time you are rejecting the undesired frequency bands. That is called frequency selection. That is selecting the ones that you need and rejecting the others that you don't want. Okay. For example, for frequency selection, what we generally use, we use different types of filters. For example, you can use low pass filter. For what purpose you use low pass filter? It is mainly used to select a band of preferred low frequencies and reject a band of undesirable high frequencies. That is, if you want low frequencies and if you want to reject high frequencies, you use low pass filter. Then what about high pass filtering? That is, we can select a band of preferred high frequencies and reject a band of undesirable low frequencies. Then another one is band pass filtering. By using a band pass filter, you can select a band of intermediate frequencies and reject both the low and high frequencies. That is, you are selecting frequencies in between low and high frequencies. Okay, by using a band pass filter. Another one is band stop filtering. It is mainly used to reject a band of intermediate frequencies and select low and high frequencies. So depending upon our frequency needs, we can use any of these type of filters. That is called frequency selection. That is, you are selecting the frequency bands which are desirable to you and we are rejecting the undesired frequency bands. Okay, so depending upon our needs, we can choose any of these filters. That is low pass filter, high pass filter, band pass filter, or band stop filter. Okay, now frequency selective filters are classified based on certain four ideal and zero phase prototypes, and these four prototypes is shown in this figure. The first one stands for frequency selective filters. The first one is of low pass, B is of high pass, C is of band pass, and D is of band stop. A stands for low pass. So these are the various representations. Okay, so due to their shape, all these filters are sometimes colloquially referred, that is, they are generally referred to as brick wall filters or top hat filters depending upon their shape. A frequency interval in which frequency response of a filter is different from 0 and is equal to 1 in ideal case is called a pass band. So that's the definition for pass band. Whereas a frequency interval in which amplitude response is ideally equal to 0 is called a stop band. So let's study the definitions. What is pass band and stop band? Then, when we speak of frequency selective filter, if you are just mentioning that, you are not mentioning anything, just you are mentioning a frequency selective filter, then that actually refers to a band pass filter. Okay. Most general cases may include multi-band filters. What are multi-band filters? They will have several stop band and pass band, and you know what stop band and pass band from the above definition. So in each of this band, the frequency response, that is modulus of h e raised to j omega, which we have studied earlier, is assumed to be a constant, but it is not necessary that it is equal to 1. So these are some specifications or characteristics. Now these are some applications of frequency selective filters. They are specifically intended to accurately or approximately in order to select some bands of frequencies and reject others. That is the first use, that is not to select some band of frequencies and reject others, what we have just mentioned now. Then what this is a definition for an ideal frequency selective filter. It is a filter that exactly passes complex exponentials at one set of frequencies without any distortion and completely rejects signals at all other frequencies. So that is the definition for an ideal frequency selective filter. Now, frequency filter can be used in various situations. The first example is to remove noise in audio recording. That is the first application. And how it is removed? Just see. For example, if a noise in an audio recording is in high frequency band than the music or voice on the recording is, then it can be removed. How? By using frequency selective filtering. So that is to remove noise. That's the first application of frequency selective filter. Another important application is in communication systems, especially in amplitude modulation systems. That is, amplitude modulation system is the transmission of information from many different sources simultaneously by putting the information from each channel into a separate frequency band and extracting the individual channels or bands at the receiver using frequency selective filters. So I will explain the meaning. That is, you are actually transmitting an information from transmitter to receiver. Okay, now at the transmitter, the information that is recorded will be transmitted to the receiver in separate channels. That is, for each information there will be separate channels, and when it reaches the receiver, what will happen? Each of these information will be received at the receiver in separate channels. So by using frequency selective filters, we can extract, that is, we can take out each of these informations from separate channels. So that is one use, that is in order to extract the informations contained in different channels. That is frequency selective filters for separating individual channels, and frequency shaping filters for adjusting the quality of the tone for a major part of any radio and television receiver. So the first application is to remove noise from any music or any audio recording systems. The second one is to select or separate the information contained from each and separate individual channels. Then after that is it is also used for shaping the signals received, because the shaping actually improves the quality of the tone, that is quality of the information content. Okay, so these are the three applications of frequency selective filters. Now there are two types of digital filters. One is FIR filter, that is finite impulse response filter, and the other one is IIR, that is infinite impulse response filter. Okay. Both of them plays an important role in digital signal processing. Among them, FIR filter is easy to design, but FIR filter The only drawback is that they require a large filter order to meet some specific design specifications. That means if we want to meet that is if we want to satisfy a particular design specification, and if we are using an FIR filter, then that order of FIR filter should be high. That is, we must, first order, second order, third order, fourth order, that is a very high order FIR filter will be required in order to meet a specific design need. Okay, but this can be overcome by using a feedback, and this is the idea behind the design of IAR filter. Why? Because IAR filter, as the name suggests, IAR stands for infinite impulse response. Okay, so from the name itself, it is seen that its impulse response is infinite and it extends over an infinite period of time. So this IAR filter in its design uses a feedback system, and since it uses a feedback system, it is very easy to implement IAR filter. That is, only few computational steps is required in the design of IAR filter. Why? Because it uses a feedback system, and this itself makes it very useful to meet specific design needs. That is, even a very small order IAR filter is enough to meet our specific design needs. Okay, but it has some drawbacks. One is that they do not match the performance, and the other one is they do not have any linear phase, that we will discuss later. So that's a advantage of using IAR filter. First one, it uses a its impulse response is infinite and it extends over an infinite period of time. And it uses a feedback in its design. So even a very low order IAR filter is well sufficient to meet specific design needs. Okay, then just an introduction about IAR filter. The first one is its definition. It is a type of digital filter whose impulse response is infinite because there is a feedback in the filter, that I already said. That is, if we put an impulse, say a single one sample followed by many zero samples, then the output what we get will be an infinite number of non-zero values. Now about the poles that we have studied, in IAR filter the poles always lie within the unit circle, and this particular peculiarity of IAR filter is mainly used to improve the frequency selectivity. That is, IAR filter, since its poles lies within the unit circle, IAR filter plays an important role in improving the frequency selectivity. That is, even a low order IAR filter is well sufficient to meet our design specifications. Then the other one is that it has exactly linear phase IR. It is not possible, that is, it does not have a linear phase. So it is only necessary to have a phase response that is sufficiently linear, that is not completely linear but sufficiently linear in the pass band. In such cases, it is often simple and more efficient to cascade, that is to combine two or more IR filters. Since it does not have a linear phase, we can combine one or two IAR filters. That is, cascading is possible. The last sentence, IR filter is designed to meet frequency selective requirements. The improved frequency selective properties of IR filters are obtained at the expense of increased coefficient sensitivity and potential instability. So these are some of the characteristics of IR filters. Now about specifications and all, that is various other characteristics of IR filters, we will continue within the next class. So just go through this theory part for today. That's it for now. Thank you.